Hello Legacy Sabers, Marsh here. So today we're going to talk about key features of graphs. What is on a graph and what do we want to know about it? You're going to want your notes. You're going to want a lot of different colors today. It's going to be really fun. And then you also want your foldable as well that I gave you in class. So tons and tons of learning targets. Determining local and absolute maxes and mins, where is the graph increasing, decreasing, and being able to state the intervals in interval notation again. Finding x's and y-intercepts, determining if a graph's continuous, how is it bounded, and if it's even, odd, or neither. So a whole bunch of stuff today. That foldable I gave you. Here's what you're going to want to do. You're going to want to cut where I have red lines, and you want to fold where I have green. So that way you can basically use it as a foldable. Right here, whoopsies. This space right here is where you can glue it into your notebook so that this guy does not run away from you because you don't want him to run away. So this is our foldable on the inside. If you open it all the way up, what we're going to do is label some of this information. First thing we're going to want to label is the x-intercepts. So x-intercepts are the point where the graph crosses the x-axis. You've heard of those before. So on this particular graph, I have 3 x-intercepts, one at -3, 0, one at 1, 0, and one at 5, 0. Now, be vigilant. Please make sure you write your x-intercepts as an ordered pair. They are a point. They are not a number. So please write your intercepts in ordered pairs. Same thing, y-intercepts, that's where you're going to cross the y-axis. You're only going to cross the y-axis once. In this case, our graph is crossing at 0, 2. So those are our intercepts. Pretty easy to identify. You've been kind of identifying them for a long time in your life. Increasing graphs. So where are you increasing? AKA from left to right, where does it look like the graph is climbing or going up? Right here on the graph, I kind of have it shaded in my yellow. That's where I am increasing. Notice it looks like it's going up. So in my case, my increasing interval, notice it starts at -infinity. So I am increasing from -infinity to -1. Notice I'm stopping at -1. We'll put a parenthesis on there. Okay? Then you also want to look again. Are you increasing? Because you can be increasing on multiple intervals on a graph. Kind of like if you're looking at a regular graph, like in science or something, or even history, and you're looking at a timeline. Notice, guys, you are talking about the x values. Because when you're looking at a timeline about national debt, you're not going to use the y values. You're going to use, well, the national debt increased between the years of 2012 and 2015. You're not going to say how much you're not going to say between the values that it increased. You're going to say the years that it increased. So in this case, we're going to want to always use the x values for increasing and decreasing. Notice I am increasing one more time as well. So we're going to use our and symbol, that union symbol. We're starting at 3. And we're going off to infinity for my increasing. Notice again I'm using my x values because they're chopping the domain up. You're talking about where on its domain are you increasing and decreasing. So decreasing is where you look like you're going downwards. So in this case I'm going downwards one place on my graph. I am decreasing from the x value, because I'm decreasing on my domain, from -1 to 3. So this is me saying from -1 to 3, those x values, I'm decreasing. I look like I'm going down, falling down the slope, if you want to think of it that way. If I drive a car, do my drawing skills here, got my car, beep beep, he'd be going down the hill, not up. And then for my yellows, if he'd be driving, he would be driving up the hill on my yellow drawings, my yellow lines. Some other things you want to be aware of on graphs: maxes and mins. Max is your tip tops, your top of your hill, the summits. The maximum is going to be your y value of the highest point. So in this case, I have a max on this graph at -1,4. That's the tip top. That would be a local max, because notice it does go forever and ever and ever. So this would be what locally is the maximum. We'll talk about that a little later in this video. But it would be the maximum of what you're looking at. And then you also want to always talk about your lows, your valleys. In this case, I have a local minimum of 3, -4. Normally, there is a couple different ways to say maxes and mins, and I will explain that in a little bit when we do an actual example without the foldable. There's about 3 different ways I've seen maxes and mins written. Either with the ordered pair is okay. I have seen just the y value, and I've also seen with the x value and the y value. So we'll talk about all those. Some stuff to be aware of as well. There's a lot of different ways to talk about x-intercepts. You're going to maybe hear me say zeros. You maybe hear me say roots. You might hear me say solutions. You might hear me say intercepts. All 4 of those words means x-intercepts. It's just interchangeable, and you need to be very aware that that vocab is interchangeable. Because if you hear me say, well, find the solutions of the graph, you're going to be like, what do you mean? What's a solution to a graph? That means find the x-intercepts. That's all that means. So being aware that there's multiple words for the same concept is very important, especially in math, because sometimes the vocab is the hardest part, which basically all this video is today is vocab and being able to identify it. So other graphs that being you're enriched, you're going to be able to find out about as well. Some key features you're going to want to know about: continuity. Being able to say that a graph is continuous, aka if I start on one side of the graph, I never should be able to pick up my pencil. I should be able to draw the entire graph. That's continuous. Basically being able to draw the entire graph without picking up your pencil. A graph that's discontinuous, oh, no hyphen, that would be one that looks like this. It's like a whoop, and then it goes doop. Something that looks really funky. You're going to be able to pick out a discontinuous graph from a mile away, because they look like they're kind of coming apart at the seams. That would be a discontinuous graph. You can't draw it. You have to actually pick up your pencil and move it. Boundedness is also another thing you're going to want to look out for. Boundedness is super easy. All it is describing between, do you have a maxes and mins, and basically an upper and lower bound. So if you are bounded below, it's because there is a number that's at the bottom, aka you have a minimum, and it's the lowest the graph ever goes. That's basically bounded below. Bounded above means you have a maximum, and it's as high as the graph goes. So this is more of the math form of it. A function f is bounded below if there is some number b that is less than or equal to every number in the range of f. I like to think of it as minimums, maximums. If you're a bounded function, that means you're above and below. So that means you have mins and maxes, but you don't go in directions. You don't go for infinity up and down or left and right. Or you don't go in infinity up and down. That would be bounded above and below. This isn't hard. It looks really difficult, but it's actually really easy to identify. Here's a couple of options about bounding. Notice this guy's bounded below. Notice he never stops, because this guy is actually going to get really flat right here and never cross that line. This would be bounded above because he has an upper bound, never goes above that line. This guy does not have any bounding because he's going to keep going up, and this guy's going to keep going down. No lower bound, no upper bound. This guy in particular, he is bounded above and below. Notice he never crosses over those two bounds of 1 and -1. So he would be called bounded because he bounces between those two. Never goes taller. I know it's a lot to take in. Other features of graphs, what's known as extrema. You find these all the time. Local maxes are the high points of the graph. You can have more than one local, oh, this should say maximum. Bad Marsh. Local max, you can have more than one max. There is an absolute max, however. That is the highest tip top, that's the highest summit you can get to. If your graph's going to go to positive infinity, you're going to say that is infinity for your absolute max. A local minimum, you can have more than one minimum, local min, and then we also have the ability to talk about absolute minimums as well. If your graph goes to negative infinity, you're going to say your absolute minimum is negative infinity. And it's going to keep going down, 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 down. Another thing, also even, odd, neither. Yes, you did this at the beginning of the year. It was the very first day we did videos together. Remember, even is symmetric about the y-axis, aka it folds over the y-axis. Odd is symmetric about the origin, aka I can flip over x and y-axis and it lays on itself. And then neither, it has neither symmetry. You'll find this guy is more common. Even in odd graphs, even is hard to come by. Odd is a little bit more common. Neither, however, is definitely the most common. So, we have gotten to an example. We're going to do one in the video, and then tomorrow when we get back to class, I will do another one with you again, so that way you're like, yes, okay, you can ask me questions and all that. So, x-intercepts, where are you crossing your x-axis? Looks like I'm crossing at -4, 0, -3, 0. Oh, this guy's like in the middle. Let's go a half. And then I'm also at 3, 0. Y-intercepts right here at -2, so that'd be 0, -2. Okay, looking at my graph, am I even, odd, or neither? So, am I crossing over the y-axis? If I fold this guy, it's not going to cross over, right? Not going to be perfect. Odd means if I fold it over the y and then fold it over the x, that's not going to work either. I have this extra hump bump that's not over here. So we are neither. Continuous. Can I draw from left to right and never pick up my pencil? Indeed. So he is continuous. Boundedness. If he's not bounded below, right? Because he keeps on going forever this way. It looks like he's bounded above, however, right? Because the tip top he gets to is right here. So we would say he's bounded. That's a U-O. Bounded above. Increasing intervals. Where am I increasing? Let me grab my highlighter here. So it looks like I'm increasing right here. Stop there. And it looks like I'm increasing again. Right there. Now remember, guys, intervals are, when you're talking increasing and decreasing, you're talking about the x values. Where on your domain are you increasing? So I'm starting at negative infinity, because we're coming from the left, because we're talking our x values. I'm increasing from negative infinity to right here on my domain, which would be, let's say, negative 3.5. How does that sound? There we go. Then I am increasing, looks like it would be negative 1.5 to, hey, stop at 2. Right there, stopping at 2. There we go. Notice increasing intervals. You're using parentheses because technically at 2 you're not increasing anymore. You're kind of starting to make the turn. It's actually out, jury's out in there on the math world. There's actually an argument if it should be parentheses or brackets. When you get to college or calc, you'll find your professor has a particular way to write it. You'll find me do parentheses or brackets, but I'll put more parentheses for you guys so I can stay consistent. Decreasing, I am decreasing from here to here, and then from there to there. So I am decreasing from negative 3.5 to negative 1.5. And then it looks like I'm also decreasing from 2 to infinity. Right there. Maxes and mins. So I have a couple of maximums. I have a maximum right here at y equals 1. Now here's where I talked about there's a couple of different ways that you can write it. You can either write it with the ordered pair, or you could say that y equals 1, or you could say the maximum occurs at x equals negative 3.5. Or you can do this, y equals 1 at x equals negative 3.5. There's a couple of different ways you're going to find that. I haven't really found a general consensus. If you just put y equals 1, that works too. It's sometimes better though to identify the x value with it so that you know where it is on the graph. And then I also have another max right here at 2, 5. So that would be y is 5 at x is 2. Now, identifying absolute and local. Both of these technically are local maximums, right? So, but this guy is definitely the absolute maximum because he's the tip-top point. He's the tallest mountain in our range, mountain range for that matter. This guy would be a local maximum, so this guy's like Everest, this guy's like Kilimanjaro, kind of a bit tall, but not as tall as Everest. So these would be my maxes. My min right here is my minimum at, what would he be? I think I said that was negative 1.5. And then negative 5.5. So y is negative 5.5 at x equals negative 1.5. Notice, guys, though, however, he is a local minimum because these guys go forever down. So this is a local guy. My absolute would be negative infinity. We actually go forever in that direction. And finally, domain and range. How far left do we go? How far right do we go? Domain, well, this guy's going to keep opening up, right? And he looks like he keeps on kind of moving over and over and over in both directions. So he is domain from negative infinity to infinity. However, range, he starts at negative infinity, and then he keeps on climbing. But notice he stops climbing because he's bounded above, and he's bounded at 5. He does hit 5, though, so we're going to put a bracket on 5. And that's the end of this video. I know it was pretty quick. Next class, I will go over another example before you start your homework as well. But that's the end of this video. See you later, Sabers.